Now let's look at the second problem. Over here is problem 2.11. In this problem, we have two specific production functions, and we want to find this elasticity of this ratio over here, this so-called MRTS elasticity with respect to x1 over x2. So let's first look at problem A over here. Problem A over here, we have this function. We have f of x1, x2 is equal to x1 to the 1/2 and x2 to the 1/2. So by some simple calculation, we will find that MRTS, after take partial derivatives, we know it's f1 over f2, and this can be simplified to x2, x1. Okay. Now, which formula are we going to use? We had three formulas in 210, and if we actually try to look at these three formulas, sigma prime provides the best way of solving this one. Let's try to use the formula of sigma prime, because we know this is the same thing as sigma, right? But the formula over here is negative MRTS and dx2 x1 over x2 x1 and dmRTS. Now, what is our MRTS? It's simply x2 over x1. So if we put this one inside, this is exactly what we have, x2 over x1. This replaces MRTS, and then we have dx2 x1. And then we divide by x2 over x1, and then dx2 x1. Do we see any difference between the numerator and the denominator? The answer is no. So they're just the same. So this one over here is exactly -1. Okay, now let's look at problem B. You may think problem B is actually pretty hard to do, but actually it's not. It's about the same. So problem B, we have this fx1, x2, and we have quite a complicated function over here. We have alpha x1 to the power p plus 1 minus alpha and x2 to the power p, and then we have 1 over p. This is rather an interesting function. Its meaning we will not try to explore, but you do the same thing. What's going to be this MRTS? Using chain rule carefully and simplify, it's f1 over f2, right? And it simplifies to this. It's going to be alpha over 1 minus alpha, and we have x1 p minus 1 over x2 to the p minus 1. Or if you try to put them together, this is what we have, x1, x2 to the power p minus 1. And then again, we have three formulas to look at which one to use. Because it's this structure x1 over x2, it reminds us to use the formula for sigma. It's MRTS and then dx1 over x2. And here we have x1 over x2 and dmRTS. Okay. Remember, d means differential. So now we put it inside. This is going to be, here we have alpha 1 minus alpha, just copy x1, x2 to the power p minus 1, and then dx1 over x2. Based on previous problems experience, we know we probably don't need to actually take all the differential because they look so similar. And here is d alpha 1 minus alpha and x1 over x2 to the power p minus 1. Now remember, d is just taking derivative, right? So the only thing we need to look at is over here. So how do we take the differential of this kind? Alpha 1 over alpha is a constant. It can be factored out. So let me write down some detail. Okay, so this is the one. We have x1, x2, and p minus 1. Again, this alpha 1 minus alpha is a constant out, and then we have d x1 over x2 and p minus 1. All right, now the chain rule. So this is going to be alpha 1 minus alpha. And then here we have p minus 1. And then we should have x1, x2, and to the p minus 2. And then dx1 over x2. You mean why this is so? This is just exact the chain rule. Remember, chain rule means take the derivative outside, then take the derivative of inside, right? But if we put this one inside, put this one back over here, put this one back over here, what do we see? We see exactly the same, because you see over here, this is x1 over x2 to the power 1, and then here we have x1 over x2 to the power p minus 2. So together it's p minus 1, and we have p minus 1 on the top. So if you look at, this is what we have. In the numerator, we have alpha, so this is sigma, minus 1 alpha, x1 over x2 to the power p minus 1, and dx1 x2. And look at the denominator. We have nearly identical expression, x1 over x2 to the power 1. And over here we have alpha 1 minus alpha and p minus 1. And then we have x1 over x2, p minus 2, and then dx1 over dx2. So we see lots of common factors. Common factor, common factor. These three together is common factor, and this is common factor. So the answer must be 1 over p minus 1. You can use sigma prime as well if you just reverse the formula over there, and then you have x2 over x1 1 minus p. But that's very, very similar. So you see that it pays if we try to look at which formula to apply, then we can have an easy computation. We don't have to do a lot of computation. Imagine if we use a formula like this one over here, then it's going to be really, really complicated. So this one over here is the worst. And we either use this one or the other one for problem 2 over here.